Hi, today we're going to have a look at two normal distribution questions I think are pretty tough. So you can see them on the screen. I'm sorry if it's a bit small, but take some time to read it. Maybe pause the video and see if you can read it, and then we're going to talk through them. But I think they're really good questions, but really tough if you've got these in an exam. So what we have here is the number of times a professional football player scores a goal from a penalty kick. And we have, it doesn't call it a probability distribution table, but that's what it is. And what I've done is I've drawn it horizontally because I just don't like looking at it vertically. And what we have here is the various probabilities that they will score k goals over 4 penalty kicks. So what this 0 means here is they've taken 4 penalty kicks but scored 0. They've taken 4 penalty kicks but scored 1. Taken 4, scored 2. And if we add all of these up, they should equal 1 because it's a probability distribution table. If they didn't equal 1, then it would be wrong. And quite often, you're asked to fill these in, not given them. Okay, so that's why I like this question, because everything is like reverse engineered. So how would you go about working these out? Well, let's have a look at this one, for example, the number 2. How many different ways could you score 2 penalties? Well, for example, you could miss the first 2 and score the second 2. Or you could score the first 2 and miss the second 2. Or you could score 1, miss 1, score 1, miss 1, etc. But how many different combinations are there? Well, you should know by now, if you're watching this video once you've finished the probability chapters, is you can use your combination notation, NCR. So we have 4 penalties and we're scoring just 2 of them. And that will give you 6. There are 6 different combinations. For this one, you'd be having 4 penalties and we're scoring 3. And there are 4 combinations. Have 4, score 4. Well, obviously, that's only one way that can happen. And we know that have 4, choose 4 is also equal to 1. So we can get out very quickly all the different ways of scoring them. But the problem is we would then normally times it by the probability, and in this case it'd be raised to the power 2, in this case it'd be raised to the power 3, and this one 4, probability of success. You know, this would be probability to 1 and this would be probability to 0. In fact, I'm going to just add this one on. So have 4 penalties, score 0. What is the probability of success? That's going to happen no times. And then what we would have here is the unsuccessful probability to the 4. I'll just pop it on this one. I'm not going to do them all. Remember, these powers have to add up to how many penalties there were. I'm not going to add it in here because it would get messy, but I think actually I will on this one because I'm going to use this one in a minute. Okay. Now, the question is, what is the probability? If I look at this one, and these aren't too much use to me, and I'll show you why. This one interests me because I've got a power of 0, and so does this one, because I have a power of 0. And because I have that, I know anything to the power of 0 is 1, and technically what's happening is it's cancelling out. And that's what you're looking for. If you start using these 2s and 3s, you're going to have a headache. Right? You're looking for things that will cancel out. So let's take this for example. We know have 4 choose 0 is 1. We know anything to the power of 0 is 1, so p to the power of 0 is 1. And we're left with 1 minus p to the power of 4, and that is equal to 0.0081. So if we do the 4th root, we get 1 minus p is equal to 0.3, and therefore p must be 0.7. If we look at this one, where the other power of 0 is, it's even quicker. Because have 4 choose 4, well that's 1. P to the power of 4, and then 1 minus p to the power of 0 is also another 1. And we know that is equal to 0.2. Oh, can't see that, can you? Hang on, let's see if I can just move that. There we go. So 0.2401. So I end up with just p to the 4 equals 0.2401. And if I do the 4th root of that, you get 0.7. So you have to approach this question by reversing what you would normally do. I think that's really hard because you have to spot the power of zeros. Now part B, let's let's just get rid of that. I'll just pause the video so I can just tidy this all up. So in part B here, I've just prepared a few little bits, but let's read the question. So now we have a second player, and the number of goals they score, given that it's a large number of penalty kicks, is approximately modelled by a normal distribution. So, and they've called that y. Why that's important is the number of penalty kicks would normally be a binomial, but because they say they've got a large sample, you could justify that you could use a normal approximation. And they're telling us some information here, but they haven't told us anything about the mean or standard deviation. So I've got the mean and I've got standard deviation squared, or just seeing it there, they actually want the variance, so they want this value squared. So you'll naturally want to go for standard deviation, but you've got to hold back a little bit because they want variance. Right, so no idea what this is, so I'm going to put the mean. But they have given us some information. So the probability it's greater than 119 is a very small number. So I know that it must be on this side. So that's 119, and this probability here is 0.02273. And we've got less than 104, so I know it's to the left of the mean because it's smaller than a half. So if I put 104 over here, I know this value is 0.2335. Right, so anytime I don't have the mean or the standard deviation, or both, I use a standard normal. So we're going to standardize these and find out how many standard deviations above or below the mean these two values are. So if I use the inverse normal with this information and the standard parameters, I get minus 0.7273, and that goes on. Okay, so that means 104 is minus 0.7273 standard deviations below the mean. And if we do the same for the 119, it's not quite 2, but I'm going to store the answers anyway. I've stored that as A, I'm going to store that as B, but I'm just going to write 2 for now. Okay, so 119 is 2 standard deviations above the mean. It's 2.000 something. Okay, so let's just do the inverse of that. So our standardizing formula is, let's write the formula, so Z is equal to our score. In this instance I should have written a Y, so let's just change that, minus the mean over the standard deviation. So we've got minus 0.7273 is equal to, oh, I've got that information, so it's equal to 104 minus the mean divided by standard deviation. So if there's only one of them, you just rearrange it now, but when there's 2 of them we don't know, we have to use simultaneous equations and eliminate one of them. So we've got 2 is equal to 119 minus the mean over the standard deviation. So let's times by the standard deviation. If you think about what we're doing here is what I said in words. So this value here is minus 0.7273 standard deviations below the mean, and the other one is 2 standard deviations above the mean. So if we subtract these now, we're going to get 15 here on the right, and we're going to get 2.72. So I didn't mean to draw that big line there. So we get 2.7277 standard deviations, and if we now divide, we get the standard deviation to be 5.4991. Okay, but they don't want the standard deviation, they want the variance, so we're going to square that, and that would give us 30.2396, and that's to 4 decimal places. Okay, but this question's even better because it wants the binomial distribution. So we better plug this in actually and find the mean. So let's take that value there and put it into probably this one. And I've got my value of B already stored. So I'm going to write B times answer, and I'm going to take that away from 119, and that gives me 107.9998. Right, I'm just going to draw a big red box around these because these are my 2 answers for the mean and the variance. But now we've got to find the binomial. This is where this question gets even better, because normally you go the other way. You're given the binomial and then you go to the normal approximation. But this time we've got the approximation, we have to go back. So let's think, if we did have a binomial, and that would be n and that would be p, that is approximately equal to y normally distributed with np and np 1 minus p, or npq. So what we know is np is equal to 107.9998, and we know np 1 minus p is equal to the variance, okay, which is 30.2396. Right, so we have two simultaneous equations, and just like before up here, I subtracted them to eliminate a variable. If I subtract them, I don't eliminate anything, so I don't want to do that. If I add them, same problem. But I can see if I divide them, the NPs are going to cancel out. So if I have this one as my numerator, I'll write it out in full so it makes perfect sense to you. But if this is my numerator and I divide it by the top equation, you can see that the NPs can cancel. Oh, it's 107.9998. So the NPs are going to cancel, so I'm left with 1 minus p is equal to this, which is 0.2799. That goes on, so I'm just going to acknowledge that. So therefore p must be 0.72. And just like before, we have an equation. I'm going to pop it into this one. So I'm just going to divide 107.9998 by my new value of p, and I get 149.999. Okay, so therefore x is distributed binomially. Did they want nearest? I can't remember what they wanted. Let's have a look. Okay, so it's discrete. Okay, so we can't have that as an answer. So let's go for 150. And let's go, the probability of scoring is 0.72. Right, and there you have it. That's a really good question. Let's have a look at another one. Let's have a look at another one. I'm just going to pause it and make sure it's there. Okay, when I first read this, I must have read it for about 5 minutes just to make sure I understood it properly. So please read it. It's really important you read this so you can appreciate how difficult this is. Now, a fair six-sided dice is rolled, and depending on what result we get, a random from a normal distribution is taken, but there's 3 different normal distributions we're looking at. So if we get a 1, so let's just write it down a little bit easier to understand. If we roll a 1, we're going to go to a distribution. Oh, it's not a binomial for sure. 1, 1. So they didn't write this x as distributed, but for me it's more familiar to see it like this, so I've just popped it in. So if we roll a 2 or a 3, we're going to go to this distribution, and that's the standard normal. If we roll a 4, a 5 or a 6, well, in that instance we're going to go to a third distribution with a mean of -1, 1. Right, so that's a little bit strange. And then we read part A and it says the probability of the outcome is between 0 and 1 given that. Okay, I'm going to underline those 2 words, really important words there. We know we're now dealing with conditional probability. So we've got conditional probability with the normal distribution. So given an odd number is rolled. So the question is, what is the probability that we're going to get between 0 and 1, given that it's odd? Okay, so, right. I always would tell all of my students, whenever you have something like this, the best thing you should do is draw a picture. So, picture 1, 2, 3. Let's put some information on. So for this one we've got a mean of 1. For the second one we've got a mean of 0. Third one we've got a mean of -1. Now the standard deviations on the first one is 1. So 2, 3, 4. Remember 99.8% of the data is within 3 standard deviations. So then we have 0, -1, -2. So the area we're looking at is this bit here. 1, 2, 3, -1, -2, -3. And the area we're looking at for this one is in here. So this would be 0, this would be 1, this would be 2. I'll just pop these numbers on, why not? And the area we're looking at here is this bit. Right, so let's work out the probabilities because we've got all the parameters we need and we've got the lower and upper, so we can just use our calculator to work these out. So that is 0.3413. This is 0.3413. And this is 0.1359. Okay, so let's look at part A. I'm just going to pop an A next to this. So we've got all the numbers we're going to need, but so it's got to be between 0 and 1, so we've got all the probabilities, but given that it's odd. So given that, so this part here on the right, the given that is always the denominator. So what is the probability of rolling an odd? Well, that's a half. Okay, so it's a fair dice. Right, but now this is like the intersection of being odd and between 0 and 1. So let's look at that first distribution. How many different odd numbers are there? Well, there is a 1 odd number, and that's a 1. So what's the probability of rolling a 1? That's 1/6. But also, we're looking at that score between 0 and 1, so it's a sixth of 0.3413. So what we're going to have to do on this top line here is look at every single distribution, because we can get a 0 to 1 score on every distribution, but we're only going to look at the ones given that it's odd. So if none of these have an odd number in, we're going to ignore them. And if they all have an odd, we're going to have 3 separate sums here. Okay? And just looking ahead, there are odds in all of them, so there are going to be 3 separate sums. So if we looked at the first distribution, given that it's odd, so we had to go to this one because it was an odd number. There was only one of them. The probability of rolling a 1 is 1 out of 6, and we're timesing it by the probability of scoring between 0 and 1 for this distribution. So let's have a look at the next one. How many odd numbers are there? There's only one, which is a 3. What's the probability of rolling a 3? 1 out of 6, and we're going to times that by 0.3413. Let's see if I can squeeze this in. Right, the third one. So there's only one odd, and that's a 5. So again, probability of rolling a 5 is 1 out of 6, and we're going to times that by 0.1359. Okay, before I type this into my calculator, I'm just going to point out something. So imagine on this second distribution that was 2 and 4, we wouldn't be using it. There would only be 2 sums here because it has to be given that it's odd, so we would ignore it. And if this one had 3 and 5, we would say how many odds are in here? Well, 2 of them, so this would now be 2/6 here, not 1/6, because there'd be 2 odd numbers. Hopefully that makes sense. Right, and you bung that in your calculator, you get 0.2729. Okay, let's have a look at part B. So in part B, the probability that one was rolled, given that the outcome. Okay, so it's like kind of reversed. So we roll a 1, given that it's between 0 and 1. Okay. So the fact that it's between 0 and 1, that's the denominator. Okay, so how many ways can we do this? So let's look at this first distribution, because on all of them we can work out, we can get a score between 0 and 1. Okay, so again, if one of the distributions didn't have a score between 0 and 1, we would be ignoring it, but in this instance it happens in all 3, so we've got to include all 3. So I'm going to have 3 sums down here. So let's look at the first one. So how many ways can we get a score between 0 and 1? Well, there's only one number that we can do it on, so the probability of rolling that is 1/6, and the probability of that happening is 0.3413. Okay. Now, the next one, how many ways can we score between 0 and 1? Well, there are two numbers we could have rolled and got into this distribution. So there are two numbers we could have rolled, so that's a 2 in 6 chance, and the probability of scoring between 0 and 1 is again 0.3413. For the third distribution, we can score between 0 and 1. How many different ways can we enter into this distribution? 3. Right, we could roll a 4, 5 or 6. So 3 ways of getting in. Right, so 3 out of 6. That's the probability of rolling a 4, 5 or 6. And we're going to times the probability of getting between 0 and 1. So the numerator is going to be the intersection between these two events. Okay, so rolling a 1 is happening and getting between 0 and 1 is happening. So that means we're only looking at this top distribution, so looking at rolling a 1. So the probability of rolling a 1 and getting between 0 and 1 is the same as this value here. So just type that into your calculator and you get an answer of 0.2384. Wow, tough questions. I hope that's really made sense. Please watch it back as many times as you need to, and best of luck.